Talking about function and notation. First thing, we will use interval notation in this class. So set builder notation is when you have like the squiggly brackets. We use that solution sets when we're solving things. But inequalities, instead of saying x is greater than 2 or x is greater than -2, we will write this interval. An interval gives a starting and a stopping point. This says x is starting at -2 and going on forever. Okay, think about a number line. Greater than -2. You're used to doing open circles. We do parentheses in here for an open circle, and it's everything larger. Interval gives starting and stopping. It starts at -2, it goes forever. A parenthesis means it's not equal to that point. A square bracket means it is. So if I said like x is greater than or equal to 1, that's everything from 1 on. We use this square bracket to show that. And it always has 2 points, the starting and the stopping. Do you guys remember using this notation in Algebra 2? Good. Infinity just means it goes forever. We have positive and negative infinity. It always gets a parenthesis. You can't equal infinity. It's not a specific number, so always use a parenthesis there. So, let's look at an example. If I ask you to write these using interval notation, some of you might just be able to write the interval. Some of you might struggle a little more. If you're not sure, I recommend thinking about a number line. You don't have to draw a super detailed one. It's saying x is greater than or equal to 1. Instead of a closed circle, we use a bracket. And it's less than or equal to 3. So it's just between 1 and 3. So my interval, equal to means bracket, small comma large, 1 comma 3. Right, and you guys should be able to just write this on your notes handout as we go through. All right, the second one. How would I write this one? Parentheses. It's saying x is between -4 and 0, but not equal to, so it's parentheses instead of brackets. So it's just parentheses, -4 comma 0, another parenthesis. If I said x is greater than 5, so not an equal to, that means a parenthesis. Greater is going to the right, so it's everything bigger. How do we write that? And both the 5 and the infinity get parentheses. If I say x is less than or equal to 1, so less than is going to the left, equal to is a square bracket. Very good. Always has to go small to large, left to right, so that negative infinity has to come first. Right. Any questions about those? Let's go the other way. If I give you the interval, can you write it as an inequality? So we have two notations. We need to be able to go back and forth between the two. And this is saying its x's are between 1 and 4. So how would we write that? So it's starting at 1, going to 4. So it's just a compound inequality. So we say 1 is less than or equal to the x, which is less than the 4. The 1 gets a bracket because it, or 1 gets an equal to because it had a bracket. 4 does not. 2 to infinity. How would we write that? X is greater than 2. We had that parenthesis, so that means it's just a greater than, not greater than or equal to. All right, what if I have 2 to 3, both with brackets? What do we write?
2 is less than or equal to x. 3 is greater than.
All right. Just one compound inequality. And the last one, negative infinity to smaller, so what would we write?
X is less than 2, negative 3.
Yeah, you're right. Perfect. Any questions there? So that's a notation we will use anytime we have inequalities. Now let's talk about functions and relation. A relation is just any kind of correspondence between two sets. Typically in math, we're talking about sets of ordered pairs. So if you think x, y, x is your input or your domain, y is the output or your range. So x, domain, y, range. A function is a special kind of relation where each input has exactly one output. That means if I pick an x value, I'm only going to get one answer out. There's no x I can plug in that gives me multiple answers. Or another way to think about it, x doesn't repeat if it's a function. So let's look at some relations, decide if they're functions, and do the domains and ranges if they are. So is this first one a function? Is it? If it's a function, each input can only give you one output. What happens if I put in 1? Sometimes I get out 3, sometimes I get out 4. The x repeated, so that is not a function. It's not a function because the 1 repeats. Okay, if it's a function, your x's cannot repeat. These are my x's. I can't have anything show up repeatedly in that column. I don't care about the y, but the x can repeat. We could still do the domain and range here. What would my domain be? Domain is your x's. So the only inputs we had were 1, 3, and 4. Even though the 1 showed up twice, I don't have to list it twice. I wouldn't be able to do an inequality here or an interval. It's just those 3 numbers, so we just list them. My range, what y's do we get out?
3, 4, 5, 2, or 2, 3, 4, 5.
Technically, you could put those in any order, so if you did write 3, 4, 5, 2, that's fine as well. Alright, is B a function?
Yes.
Yes. When I look at my x values, they're all different. 1, 2, 3, 6. So my domain is those x values. 1, 2, 3, 6. The range is your y's. What would we put?
4, 5,
Doesn't matter that the 4 repeats, we only list it once. Is C a function? Why? Negative 3 repeats. Can you tell me anyway what the domain would be? What would our range be?
9, 4, 0, 8.
Okay. D is written a little bit differently. It says the set of ordered pairs x, y, such that y is equal to x plus 2. So it's saying we have ordered pairs. X could be whatever. To get y, you do x plus 2. So if I put in a 5, I would get out 3. If I put in like negative 7, you would get out negative 9. And you could list an infinite number of pairs, right? So, is it a function? Would I ever pick an x value that would give me 2 different answers? No. So this one is a function. Domain. What can you plug in for x? Anything. How do we write that using interval notation? Think about on a number line. If it's anything, it's that entire number line. So it's coming from negative infinity and going to positive infinity. Range. Is there any y value we can't get out?
No.
No, we can get anything. So the range would also be negative infinity, positive Are those okay? Let's practice domain and range from a graph. So, domain is the x, range is the y. You can't tell from your picture, I know it's a little hard on that small slide. A is just these 4 points. So my domain is just listing those 4 points. What would they be?
2, 2, 3, -1, 3, 4, 1, 2, 4.
Okay. So these are the points that you were telling me. The domain, though, is which part of that point? Yeah, the x. So it's the -2, -1, 1, and 4. The range is the y value of those ordered pairs. So that would be the -3, -2, 3, and 4. Alright. B. So domain is referring to the x. So this one is a little bit different. I don't just have certain points, so we have to think about our x's. One way to do that is think about like if I took a vertical line. Okay. Okay, here's a vertical line. As I go from left to right, small to large, what is the first place that hits an x? -1. And it does hit it, so that gets a bracket. Comma. As we keep going, we're hitting all these points on the circle. Where is the last place we hit? +5. And it does hit it, so it's everything from -1 to 5. All right, your range is your y. So to think about that, think about a horizontal line. We're going from the bottom to the top. So as I'm taking that, what is the lowest value we hit? -4. And it does hit that, so it gets a bracket. And as it keeps going up, we're hitting points, hitting points, hitting points. Where does it stop? Is that one okay? All right, C. So this is just a line. It keeps going forever. So as I take my vertical line going from left to right, keep in mind this line keeps extending. Is there anything we wouldn't eventually hit? No. As I travel, we are going to hit all of those at some point. So it will be -infinity to +infinity. Range is my y. Now, this line keeps going down, so it's going down forever. And it keeps going up forever, so what y values do we hit? All right, D. Think about your x. As you go from left to right, as this parabola keeps going, it just keeps getting wider and wider and wider. Is there anything we won't eventually hit? No, so domain is? What is our range? How would I write that? You have to go from the
0 or bracket 0 infinity.
Yes, starts at 0, equals to 0, so it gets a bracket, keeps going up forever, so 0 to infinity. All right. How do you look at a graph and know if it's a function? Yes. Passes the vertical line test. So if I looked at those 4 graphs, was the first one a function? Yes. Is B? No, because I can draw lots of vertical lines that hit it multiple times. Is C?
It is.
Is D?
No.
Is it?
Yes.
Yeah, as I draw vertical lines, they only hit once. Okay, I want you guys to look at these four, write down yes or no. Are they a function? Yes. This doesn't turn into a vertical line, it's getting wider and wider, so it will continue to be a function. Is the second one? No, we can draw vertical lines that hit multiple times. Is the third one? No. Again, fails vertical line test. About this one? Yeah, it's flattening out for a little bit, but it never just turns vertical. It still passes vertical line test, so that is a function. All right, if something's a function, a lot of times we will see function notation. That's your f of x. That replaces the y. So if I had an ordered pair 2, 13, it means f of 2 equals 13. The number you plug in is x, the answer you get out is your y. So using that idea, let's evaluate each of these functions. So if I give you an equation, how do you find f of negative 1? Alright, make sure you're careful there. Negative 1 squared becomes? Yeah, 1 times 2 is 2. 2 minus 9 is negative 7. What if I gave you ordered pairs? How do you find f of negative 1? It is a great question. Oh, come on. What does negative 1 represent? Okay, so it's saying if x is negative 1, find y. So look at these ordered pairs. Find the point when x is negative 1. What's our y? Free day Friday, huh?
So helpful.
All right, what about c? What's f of negative 1? 5. You find the point when x is negative 1, and the y value is 5. D, when the x is negative 1. So look at my graph. Here's negative 1. It hits this point on my graph. What's the y value there?
0.
Maybe 0.5. Do we have questions on any?
Yeah, I got a question. So, is Free Day Friday still okay?
No, never. Just because of you guys. All right, so let's say my function is 5 minus 2x. So if I ask for f of 4, what am I asking you to do? But sometimes you may not be asked to plug in a number, so you don't have to get a number answer. If I put in f of a, so you get 5 minus 2, I'm just replacing my x with a. So it's 5 minus 2a. Are those like terms? We can't subtract them. That's my answer. Just 5 minus 2a. I ask you to find f of a plus h. That means you are replacing x with a plus h. We have 5 minus 2 times a plus h. What should I do there? Distribute negative 2. So that's negative 2a minus 2h. And again, no like terms, so that's our final answer. Last one, if I say f of 5x, that means I'm taking the x in the original equation, I'm plugging in a 5x in its spot. So what does that give me? And again, in, not like terms, so that's our answer. So you don't only plug in numbers, sometimes we're plugging in other variables or expressions. Alright, do you guys have any questions? Alright, so if you had any trouble with yesterday's Math Excel assignment, you have time now to ask those questions. There is a new Math Excel assignment open, and you guys have a lot of time.